Good morning. Today we will start the first lesson as a distance learning class. We trying to finish chapter 6 trigonometry in math P2. As you know, we started teaching this chapter last week in the school. I'm trying to finish this chapter in order to start the next chapter, which is chapter 7 and chapter 8. As you know, still we have calculus, 2 chapters more. As you know, trigonometry as a revision, we have 2 basic identities in this chapter. We have 2 basic identities. What are these 2 basic identities? The first one, sine squared the angle theta plus cosine squared the same angle theta is always 1. And the second identity, tan theta, as you know, it is sine theta over cosine theta. So these 2 basic identities are very important in this chapter, and the type of questions on these 2 identities prove or show that and solve trigonometrical equations. Okay. We have many questions and exercises how to show that or simplify some identities, but the most important question is to solve trigonometrical equations, and we already solved last week many questions, but I just want to remind you how to solve trigonometrical equations. If we have sine theta equals k, you have to put theta as sine inverse k, so the calculator will give you alpha. Take the other choice, which is alpha 180 minus alpha. You have to add the periods, 360 degrees n for the first one plus 360 degrees n for the second one. This is if the angle in degrees. If it's in radians, you have to put alpha plus 2 pi n, pi minus alpha plus 2 pi n. And you know that n is 0, positive or negative 1. You have to try positive or negative 2, and so on, to get all the angles inside the interval or the given interval. What about if cosine given? If cosine theta in the equation is k, so theta is cosine inverse k, the calculator will give you alpha. You have to take the other choice, which is negative alpha. Add the period, 360 degrees n plus 360 degrees n. If it's in degrees. If it's in radians, you have to add alpha plus 2 pi n, negative alpha plus 2 pi n. N as usual 0, positive or negative 1, positive or negative 2, and so on. I'm going fast in these formulas because we already have it last week in the school. Just to revise it again, what about if the angle tan or the trigonometrical ratios is tan theta equals k? What is theta again? It's tan inverse k. The calculator will give us alpha. Don't take other angle, but add the period. The period for tan is 180 degrees n. If it's in degrees, if it's in radians, you have to add alpha plus pi n. Let's see a question. How to use this formula again. Just to remind you, this is only a revision for what happened last week in order to finish this chapter and to let you how to solve the chapter review at the end of the chapter in order to travel to the next chapter, which is differentiation. I will choose a question from P2 June 2019. Let's see. Trigonometrical questions. Okay, let's see. This question is a combining between chapter 1 and chapter 6. Look at this question again. It's a question 6 from June 2019, P2. F of x is kx cubed minus 15x squared minus 32x minus 12. Given that x minus 3 is a factor, show that k is 9. You know that if x minus 3 is a factor, so when you substitute 3 in the function, the remainder is what? Is 0. This is the way how to find the value of k. So f of 3 equals to what? To 0, because x minus 3 is a factor. F of 3 is k times 3 cube instead of x pot 3 minus 15 3 squared minus 32 times 3 minus 12 equals to what? To 0. 27k minus 3 squared is 9, 9 times 15, 9 times 15 is 135, using the calculator of course, minus 96 minus 12 equals to 0. Now 27k minus 135 minus 96 minus 12 all together are negative 243 equals to what? To 0. So 27k equals 243 if you put 243 to the other side. So k is dividing by 27 is 9. So this is a type of show that question. K equals to what? To 9. Now to solve B, use algebra showing all your steps, fully factorize f of x. You know that x minus 3 is a factor, so the other factors you have to do the long division. I'm trying to do the long division. You know the value of k now. 9k cubed minus 15x squared, 9x cubed I'm trying to fix it. 9x cubed minus 15x squared minus 32x minus 12 divided by x minus 3. 9x cubed divided by x minus 3. 9 divided by 1, it's 9. X cubed divided by x is x squared. X squared multiplied by x is 9x cubed. 9x squared multiplied by negative 3 is negative 27x squared. Subtract negative 15 plus 27, because negative 15 minus 27, it will be positive 27. The answer is a 12x squared minus 32x minus 12. 12x squared divided by x is positive 12x. 12x times x is a 12x squared. 12x times negative 3, negative 36x. Subtract negative 32 plus 36 is 4x minus 12. 4x divided by x is positive 4. 4 multiplied by x is 4x minus what? 12. When you subtract, the remainder is what? 0. So f of x can be written as one of the factors is x minus 3, multiply by the quotient. What was the quotient? This is the quotient from the long division. It's 9x squared plus 12x plus what? 4. This factorization is not fully. You have to factorize more. X minus 3, open 2 brackets. 9x times x. No, you will never get this answer. Try another way. 3x times 3x, and 4 is 4 times 1. 12x. So try 2 and 2 maybe. 6 and 6, it's a 12. Yes. So it's a 3x plus 2, 3x plus 2, and the answer is x minus 3 and 2x plus 3 all, or 3x plus 2 all squared. Let's write it again. Uh, 3x plus 2 all squared. This is a fully factorization of f of x. Now, this part C from the question, he said that to solve this trigonometrical equation, you know, any equation has cosine or sine is called trigonometrical equation. But when you compare this equation by the first one, cubic equation, it's the same. Instead of x, he put cosine theta. If you write again, 9x cubed minus 15x squared minus 32x minus 12, which is the same as the first equation. I'm trying to return back. Okay, this is the question again. When you compare this equation by the trigonometrical equation, you have the same, which is already factorized here. So you can replace cosine theta by x. So in part C, instead of solving this, we can solve cosine theta cosine theta minus cosine theta minus 3, or 3 cosine theta plus 2 all squared, and this is equals to what? To 0. So either cosine theta is 3 or cosine theta is negative 2 over 3. You know that cosine theta as a 3 has no answers because we have a range for cosine. If you remember the cosine, it has a range between 1 and negative 1. So you will never ever find an angle has a cosine more than 1 or less than negative 1. So let's go to the second part. Theta, it's in degrees or in radians. We have to check the interval in degrees. So set your calculator mode in degrees before anything. Then write theta as cosine inverse negative 2 over 3. The calculator will give you 131.8, and you have to take negative 131.8, as we said before when we revise trigonometry. You remember, for cosine it's alpha and negative alpha, so you can add 360 degrees for the first one plus 360 degrees n plus 360 degrees n. Now, when n 0, substitute 0 here. 0 times the 360 is 0. 138 within the interval. Let's remember the interval again. The interval from 0 to 360 for rotation. So 131, theta is 131.8. This is the first answer. Let's see what's the degree of accuracy required. We have to give the answer to 1 decimal place. Look here. Give the answer to 1 decimal place. So let's return back. Let's continue again. 138, 131.8, the first if n is 0. When n 0 here, the answer is negative 131.8, which is outside the range of, but when you try 1, it's 131.8 and plus 360, which is more than 360 degrees, so we cannot accept this. But when n1 here, 360 degrees minus 138.1, the answer is 228.2. And this is the two angles inside the interval we can accept as a solution for the equation. Okay, thank you, and next lesson inshallah we will start with differentiation. Bye.